We are now going to have a look at sketching some cubic graphs, and when you get to these questions in tests, you can be sure it's worth a fair chunk of marks and it's a fair bit of working out. So make sure you just work through it slowly and carefully, follow the steps, and you should get there quite easily. Alright, so we've been asked to sketch our f of x function, which is x cubed minus 6x squared plus 9x minus 4, okay? Remember, I gave you all those steps for sketching a cubic function. Follow those, okay? That's there to kind of just give you a bit of structure and a bit of a path to follow. So know that, all right? Okay, so we're going to follow the steps, and let's start with step 1. Okay, step 1, I said, just determine the shape of your graph, more or less. Nothing perfect, just show me more or less what it's going to look like. How do I do that? I look at the coefficient of your x cubed and I see if it's positive or negative, which in this case it's positive. So straight away I know that my graph's got to look something like that, okay? So at the end of the day I need to go back and just check, have I got the right shape? Secondly, we look for the y-intercept. Now remember, the y-intercept is very straightforward, because to work out a y-intercept, let's just do that again. Let x equal 0. And if I let x equal 0, well, that would become 0, 0, 0. And actually, we'll end up just getting negative 4. So your last term, your constant term, is the y-intercept. So therefore, the y-intercept is going to be 0 and negative 4. So those are easy. Okay. It's the next step that involves a bit more time and working out. So it's just one of those things. But we have to work out the x-intercepts, and in order to do that, we say let y equal 0. Now, if that's the case, this is what I'm sitting with. 0 is equal to x cubed minus 6x squared plus 9x minus 4, okay? Now, remember, this is going to require that long division, okay, where we have to, by trial and error, start by substituting something into x to see if we can find a factor, and then from there we can factorize it. Okay, so by trial and error, I'm going to substitute a value into x. The goal is I'm trying to get 0. Okay, the second I get a 0, then we know we've got a factor. All right, so by trial and error, I'm going to start by substituting 1 into my x's. Okay, I'd like you to actually give it a try. Pause it for a second. Substitute 1 into your x's and tell me what you find. All right? Okay, I hope what you found was that you got 0. Okay, so you got 0 equals 0 by substituting 1 into those factors. So, excellent. Sometimes trial and error, you hit it first time. If it don't hit it first time, then you have to try other factors. And remember that negative 1 is a possibility. 2 is a possibility. Negative 2 is a possibility. So you've got to try the positives as well as the negatives. But if x equals 1 is correct, then if I make 1 jump back over the equal sign, then it becomes x minus 1. And x minus 1 is a factor. Okay, so we've established that when I take this cubic equation and I break it up and I factor it into 3 brackets, what I've established already is that x minus 1 is one of the brackets, okay? Now we need to work out what the other 2 brackets are. And in order to do that, we essentially need to know how many times does x minus 1 divide into your f of x function, all right? Now we can do this by long division, but there are easier and simpler ways to do it. You may have learned a method in class which I'm not going to use here, and that's fine. Use the methods that work for you, and if they don't always match what I'm doing, that's fine. As long as our final answers match, that's the most important thing. I'm going to use what we call synthetic division. Okay, synthetic division, we draw our divide sign upside down. If x minus 1 is a factor, then I put my plus 1 over there, all right? And I fill in the coefficient of each term. Now remember, the coefficient of this term over here, let's just write it in red. The coefficient is 1. The coefficient is negative 6. The coefficient is 9. The coefficient is 4. Okay, so those are the coefficients that I'm writing. 1 minus 6 plus 9 minus 4. All right, and we have done this in previous videos when we did remainder and factor theorem. So if you need to go and revise synthetic division, go and watch those videos. But basically the method is that the first term gets written down at the bottom as is. then we take 1 times 1, which is 1, and negative 6 plus 1 is negative 5. I say 1 times by negative 5 is negative 5, and 9 minus 5 gives me 4. 1 times by 4 is 4, and negative 4 plus 4 is 0. The reason why I've done a little double line over there is because the last term always represents the remainder, which, because it's a factor, has to be a remainder of 0. Now we fill in our x terms. So I've got 1x squared minus 5x plus 4. That's the trinomial that we had left, which if we factorize is x and x, 4 and 1, negative and negative. Remember, okay, so therefore, what are the 3 brackets that your trinomial has factored into? I've got x minus 1, I've got x minus 4, and I've got another x minus 1. And we're letting it equal 0 because don't forget, what are we doing? We are finding our x-intercept, so we're letting y equal 0. So therefore, what are my x-intercepts? I've got x is equal to 1, I've got x is equal to 4, and I've got another x is equal to 1, so I'm not going to write it again. We've already got it there. And those are my x-intercepts. Okay, right, so that step is always the one that's going to take you the time. All right. Step 4, we're looking for your stationary points. And by now we should be very familiar with the fact that if you are looking for a stationary point, we let the derivative equal 0. Okay? Right, so the derivative of your function is 3x squared minus 12x plus 9, and we're letting that derivative equal 0. You need to take out your highest common factor, which is going to leave you with x squared minus 4x plus 3, and you need to factorize the trinomial. All right, so we've got our x and our x, we've got 3 and 1, both negative. So the x coordinates of your turning points are 3 and 1. Remember, for a turning point, however, you need both an x and a y coordinate. So we're going to work out what f of 3 is, and we're going to work out what f of 1 is, okay? F of 3, when you substitute it into your sum, will work out at 4, and f of 1 works out as 0. So what are the coordinates of your stationary points? It is 3 and negative 4, and it is 1 and 0. Right, last thing. Point of inflection, POI. All right, we know point of inflection is second derivative equals 0. Okay, second derivative, that works out to be 6x minus 12, and we're letting that equal 0. That's giving me an x value of 2. And if I substitute 2 into your f of x equation, so if I look at f of 2, we'll end up getting negative 2. So your point of inflection is at the point 2 and negative 2. Once you've got all of that, now we have to plot. Okay, so now it's a case of getting your x and your y axis in ready. So let's give ourselves an x and a y axis. Okay, let's draw it nicely over here. Okay, and what are the points that we have? Okay, we knew that the x-intercepts were at positive 1, positive 4. All right. We knew that we had a y-intercept at negative 4. We had a turning point at 3, and we had a turning point of 3 and negative 4, so that was a turning point. So I'm actually going to mark a turning point with a little x over there. We also had a turning point at 1 and 0, so that's another turning point we had over there. Right, and the point of inflection, sorry, a point of inflection was 2 and negative 2, so this point here is where your graph goes from being concave down to becoming concave up. Okay. Right, so now let's sketch it. We know that it needs to be a positive graph. Let's just scroll back here. It has to start by increasing, okay? So that means that from negative infinity, my graph is going to have to increase up through my y-intercept. It's going to hit this point over here. Now, That's an x-intercept and it's a turning point. Whenever that doubles up, it means it bounces off your x-axis, it goes to your next turning point and up through 4, which was your other x-intercept. And there we go. All right. This was your F. This graph represents your F. You do want to make sure you are good about filling in all your coordinate points, okay? Make sure you tell everybody what your point of inflection is. Tell everybody what your turning points are, just so there's no confusion, and you should get a great mark for that sketching. Okay, well done. Lots of work, but worth it. See you next time.